Hello Math 30-1, welcome back. Today we're going to look at part 2 of factoring polynomials. And in this case here, all we're doing is we're going to look at the rational zero theorem. And what is that saying is we're going to look when our leading coefficient is something other than 1. Okay? So let's start off here with part 1. It says state the zeros of the polynomial function. So all we have to do is we look at my two factors. This polynomial function is nicely factored for us already. And I get 3x subtract 2 is equal to 0. And then solve for x, which will end up giving me x is equal to 2 over 3. Make my other factor equal to 0. 5x subtract 8 is equal to 0. X is equal to 8 over 5. Okay? Now it asks, what do you notice about the constant term in the polynomial and the two terms in the factors? Okay? So here's my constant term, my polynomial. My two constant terms in my factors, if I multiply these together, 2 multiplied by 8, it's going to give me 16, which is the constant term in my polynomial. So that means the product of my two terms, of my two constant terms, in the factors equals my polynomial constant term. Okay, so now the next part says, what do you notice about the leading coefficients in the polynomial and the leading coefficients in the factors? So I look at my leading coefficients here. We have 3 and 5. Well, 3 times 5 is the same as 16. So looking at this 3 and this 5, that gives me 15. So we have, so in this case, the coefficients of my factors gives me the product of the coefficient of the factors gives me my polynomial. Leading coefficient. Okay? So, how do the zeros relate to the coefficients in the polynomials? So now we're going to look at my zeros here. Okay? So, if we look at that, basically what's happening is my numerators are equal to my constant term. So product of numerators is my constant. And we also know that the product of the denominators is equal to my leading coefficient. Okay. Now, part B is pretty much the same thing here, except we have a cubic function and it's given the factors. And if we do this investigation, all you're going to find out is the same thing, that if we multiply these here together, our constants together, it's going to give us 231, and if we multiply our leading coefficient or our coefficients together, they will equal to the leading coefficient. So it's just reinforcing our rational theorem. Okay, our rational zero theorem. which states that the zeros of an integral polynomial px are of the form p over q, where the numerator p is a factor of the constant term and the denominator q is the factor of the leading coefficient. So here we look at it, p is my factor of the constant term, and we have q is the factor of the leading coefficient. Okay? So now let's look at class example number 1. Now, before we start class example number 1, we're going to look at it above here. It already factors -9 for us. It's either plus or minus 1, plus or minus 3, and plus or minus 9. It also factors my leading coefficient, which is of 5, which is plus or minus 5. So then it gives us all of our possible constant terms and factors, which are all of these combinations here. So now it says, use the potential zeros above to list the potential binomial factors. We want to know all my potential factors. Well, if I look at this, we have x plus 1 and we have x minus 1. Okay, so that one's done. Now we have plus or minus 3, so it's going to be x plus 3 and x subtract 3. This one here is done. We have x plus or minus 9, so I have x plus 9 and x subtract 9. That one's done. I have x plus or minus 1 over 5. So remember, this here is my coefficient. So that's going to be 5x plus 5. And then 5x subtract, 1. It should be 1, not 5. So it should be plus 1. Okay? Because this here is my constant, that's my coefficient. And then we're going to have 5x plus 3 and 5x subtract 3. And then last we're going to have 5x plus 9 as a possibility and 5x subtract 9 as my last possibility. So these are all of my possible factors. Now it wants us to show that x is equal to 1 is a zero of the polynomial px, and hence determine all zeros of the factor. Okay, so first we're going to try this one here. So I'm going to do this using long division. Okay, so we're going to put when x is equal to 1, and we have 5 x cubes, and we have 51 x squareds, and then we have 55 x's and 9 constants. Okay, so those are my terms. So we bring on 5. 5 times 1 is going to give me 5. We add these together. I am going to end up getting negative 46. 1 times it is negative 46. Put these together, that's going to give me 9. And we have 9, and that's 0. Okay? So, we now know that p of x is equal to x minus 1, because remember, this was make this equal to 0, so we put this part here, make it equal to 0, so we move the 1 over to make it equal to 0, all multiplied by 5x squared minus 46x plus 9. Okay? So now we're going to try and factor this one here. And if I factor that, we could use box method, whichever way you want. We're going to end up getting x minus 1 multiplied by x minus 9 and 5x minus 1. Okay? So we can use box method or whichever way. So my zeros are going to be 1, 9, and and 1 over 5. Okay? So all I do is we have this here, the same as x is equal to 1. This here is x is equal to 9. Make it solve for 0. This is 5, or x is equal to 1 over 5. Alright? Okay. So now it says for C, solve the equation. So for this one, if we were to solve the equation, we get x is equal to 1, 9, 1 over 5, which is just my 0. So now the next one here, second class example, it says determine all solutions to this following equation. So I'm going to look at this here. First of all, we have to say what are the possible real solutions. So my potential zeros are going to be first I'm going to look at my denominators, which could be plus or minus 1 and plus or minus 3. Okay? My potential denominators could be are plus or minus 1 or plus or minus 2. Okay? So now I'm going to look at all my combinations. I could have over 1, I could have plus or minus 1 over 1 and plus or minus 3 over 1. Or I could have plus or minus 1 over 2 and plus or minus 3 over 2. Okay? So those are all of my potentials. So now we're going to try and use a little bit of guessing here and seeing which one works the best. So for the first one, I am going to look at, let's try 3 over 2. Okay, so we're going to look at 3 over 2. So I'm going to go P of 3 over 2 is, double check here, it's going to be 2 times 3 over 2 to the cubed and minus 3 over 2 squared minus 3 over 2, and then we have to minus 3 is equal to 0. Okay, so we look at this here. 3 cubed is the same as 27, and divided by 4, but then we times by 2, so it's going to be 27 all over 2. Okay, 3 squared and 2 squared, all over 4, sorry, because that should be cubed is 8. So now here we're going to have 3 squared is 9, 2 squared is 4, then we have subtract 3 over 2, and then subtract 3. So to solve these, we're going to we need all of these to have a common denominator. So that's going to give me 27 over 4 minus 8 minus 9 over 4 minus, and we have to 6 over 4, and this one here we have to go 12 minus 12 over 4. So I combine all these up together, that's going to give me 0. So now I know 3 over 2 works. Okay? So one of my factors is, we know that x, 3x or 2x minus 3 is one of my factors. So let's figure out what that is. I'm going to put in, right here, we're going to put in 3 over 2. And we have 2x cubed minus 1 minus 1 minus 3. Solve for this here. We have 3 over 2 times 2 is 3. When we add those together, I'm going to get 2. This is going to give me 3 again. Add those together, I'm going to get 2. This is going to give me 3 again. I get 0. Okay? So, this is the equivalent to, we know now that P of x, or 0, is equal to 2x minus 3 multiplied by x squared, or 2x squared minus 2x minus 2. And we're going to try and factor that out there. So we could factor out, first of all, a 2. So it's the same as 2x minus 3, because 2 divides each of these. So we're going to be left with x squared minus x minus, plus x. And then we're going to have, it should be plus 1. Okay? Now, if I look at this here, in order to factor this, that doesn't factor very easily, so now I'm going to have to use the quadratic formula. So we know that x is equal to minus b plus or minus the square root of b squared minus 4ac all divided by 2a, which is going to give me negative, and my b value is 1, negative 1, plus or minus the square root of, and we have 1 squared minus 4 times 1 multiplied by 1 all over 2. But if I look at this here, if you remember from back before, that's going to give me a negative inside the square root, so that is impossible. So theoretically, there's only one real solution to this, because we can't square root negative. So my only solution is x can only be equal to 3 over 2, and that is my only solution to this equation.